Hello, my name is Steve Goodwin, and you are watching my anchor test video number 109. In it, we will review this 44-pound stainless steel Lewmar Epsilon Anchor. The anchor did come out at 42 pounds on my scale, and in the setting position, the tip came out at 13 pounds for a tip to total weight ratio of 31%. The anchor was submitted to me for testing by an individual in brand new condition, and I gotta say, when I first got it, the polishing was exquisite. I have since tested this anchor in coarse sands and the cobblestone, so the really high luster has been toned down a bit, but I believe with some polishing that could be brought back. I don't see any deep, heavy scratching, so it should polish up real nice again. As far as the engineering and strength is concerned, unfortunately, I do not know which grade of metal this shank is made of. I know that the much longer and slender shanks can really benefit from the very high strength steels that are available in the galvanized anchors, but this anchor shank is the shortest of any that I've tested in the 40-pound range. So in spite of the lack of knowledge about the grade, I think we got plenty of height, plenty of width, and so short, it's probably not going to be an issue of shank bending. Toe isn't going to bend under any circumstances, in my opinion. We've got a thickened toe, it's ballasted, and there's just so much material there. Even if stuck under a rock and lifting up, I don't see bending the toe. We don't have the presence of tall roll bars or other appendages, so overall, plenty stout. I do not know how this anchor was built, but I'm going to guess that it was made up of folded plate. For instance, this fillet here was likely welded in place, and the welds were then nicely ground out and sanded. Lots of man hours there. The price is favorable. It's about half the price of a similarly sized Ultra anchor, and their galvanized anchors are also much less than most of the other anchors. I'll comment a bit about this design in general. First is the fillet, and I gotta believe that was not done for structural reasons. I believe what they were trying to do is minimize mud packing in between the fluke and the shank, and I'm not going to tell you. I'm going to let you decide whether or not that works or not in my testing, and especially the reset testing. Also, the anchor has radically turned up edges, trailing edges of the fluke. There's this gap between the two halves. I'm just guessing that maybe they allowed or provided this hole here as sort of a hole in the fluke, which might allow seabed to not get stuck here. Another unique feature is the optional roll bar that's provided. It just bolts to the fluke like this. And it's my view that the whole purpose of a roll bar is just to help the anchor right itself and get into the setting position. After that, it's my view that a roll bar is actually a hindrance. So if the anchor works without it, that would be the preference. But let's just see on the workbench if it has any trouble self-righting. So here's the anchor. If it landed completely upside down, obviously it would get to this point easily, and it gets to that point just fine. But here, there's a spot where it will not self-right. However, just the slightest little bit of jostling, and it will then go into this position, and it has lots of tip weight, no problem from that point. So now let's put the roll bar on and see if it helps that. Okay, with the roll bar affixed, let's see how it works. And obviously, if it's upside down, it will roll to this position, no problem. And this was the point where without the roll bar, it was sort of stuck, or it wouldn't self-right. And indeed, the situation hasn't changed. In fact, I can just see it right now. No part of the roll bar is touching the table. The points of contact haven't changed. And unfortunately, the weight of this roll bar is actually making the situation worse. I think the anchor will still attain the right position with a little bit of movement, a little bit of jostling, because it's still pretty much right on the edge. But I can tell you that the roll bar really is no help. Okay, maybe in a very, very soft seabed, Okay, maybe we've got some extra surface area as the anchor sort of pushes down into the seabed. Maybe that would help in that case. But here on the bench, yeah, I don't see a real need for this. And again, it's my view that roll bars are generally a hindrance to anchor performance. Once the anchor has set, there's the potential for it to catch mud and not let things slide by as the anchor attempts to penetrate deep into the seabed. So I did test it in both conditions, but I favored and did most of the testing without the roll bar. The roll bar testing comes at the end of the video. The chain attach hole can accommodate a wide range of shackle sizes. Here's a 5/16 shackle, 3/8, 7/16 fits through no problem, no binding, and even a 1/2-inch shackle fits no problem. Last thing I'll mention before we get to that footage is the self-launching power was very high, as good as any anchor. I was able to drag a full 16 feet of the chain and its self-launching ability. Okay, that's enough shop talk. Let's get to that footage. Okay, we'll start off with a veering test in the clean, loose sand seabed. I'm using 150 foot of road and 30 feet of water. Normally it's 165 and 33 feet of water. Same scope, but slightly less favorable due to the less length. Also, because of an extremely low tide, I'm close to the edge of a shelf, and it's just a different location. So this anchor does release at the 150 degree mark. And so let's go ahead and toss out this pull. I'm going to show you a couple more here. And again, I think it's being pulled down slope at this time, which is less favorable. The anchor did not reset. So let's give it a break and toss that one out. Okay, we'll give the anchor another shot, but this time we're in 25 feet of water. I've left the road the same at 150 feet, so it's 6-1. It's got a definite advantage now, and this is in the more flat or level part of this sand shelf. But in spite of the advantage of having longer scope, the anchor releases at 5 degrees of veer. I have tested 2 other anchors in this size range in this test. Those were the 44-pound Mantis M2 and a 51-pound Viking. They both were able to withhold the baseline pull setting and execute the full 180 degrees of veer. So this anchor appears to be deficient in this seabed and at this test. The anchor did reset on this pull, however. We can see the shank in the lower part. It is upright, and it appears the anchor is reburying completely. But the anchor was unable to hold the 840-pound target. It was at 750 pounds. The anchor's well out of sight, but it releases completely and then did not reset. I did give the anchor a third and final try at this favorable 6-1 scope. Did not matter. The anchor released right at the beginning of the veer. I have tested 20-pound anchors in a similar test, and there's a couple of them that I would say are far better than this anchor that is more than twice as large. Next test is in the Cobblestone seabed. It's just a straight line pull with lots of scope. My goal is to have effectively infinite scope at the anchor or no chain lifting, but it does not matter. This anchor fails completely. We have the toe slightly dug in at this point. This was the most holding I was able to get it to register. It's 115 pounds of thrust, and much of that is probably simply the chain laying on the bottom. The only other large anchor or anchor of this size that failed to make significant holding power was the CQR. and many 20-pound anchors were able to hold much more than this. So this is an easy test to report on. It's pretty much a complete failure. Next test is a veering test in the soft mud at Scow Bay. Now there's not a lot of current here today, so any particulate that you see in the water column that is moving, that's an indication that the anchor is moving. And we can see as I'm ramping up toward the target of 500 pounds, there's intermittent movement. Those particles are very close to the camera, so if you don't see a lot of movement, there's not a lot happening. But as we approach the 500-pound target, the motion picks up and it does not stop. And in fact, it reaches 2 knots on the GPS in the boat, and you can see the camera tethers now drifting away. That's our sign, and sure enough, the anchor has released fully. The anchor did not reset. However, on retrieval, all of the mud that was presumably packed in had fallen away. I did give the anchor another try here in the soft mud. The target this time was just 395 pounds for the veer, but I couldn't make it. It released at 335. Again, there's multiple 20-pound range anchors that could hold more than 500 pounds in this seabed. So again, severely deficient in the soft mud. Next is another veering test, this time in sandy mud. Using an all-rope rode with generous scope, shooting for an 840-pound baseline pulling force. And it did achieve the 840 pounds, and then right away at the 20-degree mark of the veer, the anchor does release. You can see some heaping going on. To the right there, we see seabed that was lifting up, and sure enough, the whole anchor lifted out of the seabed with a large wad of mud attached to it. But I could tell that the anchor had dug back in and reset firmly. So I thought, well, let's go ahead and continue with the test. It did hold the 840 pounds, and it held a lot of the veer. It swung right around, and I thought we were going to make it to 180 degrees, but it did not. It released at the 170 degree mark again. Slow the camera. This is normal playback speed, so you can see its release and resetting once again. And now I've got the camera speed back up to 8 times. It reset nicely again, and then continued the veer through 220 degrees, and then it was holding. So I stopped at that point and then initiated a ramp up of pulling force just in a straight line. And at 1,020 pounds, the anchor released fully. So I wouldn't call this performance terrible, but it is certainly below average for the 40-pound range anchors. Note that mud is packed only on the side of the direction of the veer. This will be another sandy mud test, this time 180 degree reset testing. I'm driving the boat up and over the anchor. I'm shooting for a direct 180 degree reversal. This is the short chain version of this testing, and when you use short chain, you end up with a backflip or a full release every time, and that's the way it is with just about every anchor I've ever tested. With longer chain, you get pivots in the seabed, and no release, but short chain, you get these releases. Now this anchor does reset every time. What we just saw was one of the longer reset distances, but again, it gets the job done and stops the boat. I give it a good burst of power. It's well over 500 pounds of thrust after the reset just to make sure it's firmly engaged, and this anchor was each and every time. I'm not going to show you all 10 of these resets. I'll give you 5 of them, because it's boring. The thing that just does the same thing over and over. Sometimes you get a nice short reset like that one, and other times you get a little longer. I'm going to guess maybe 10 or 15 feet on the longer ones. And this last one here I'll show you. That was, I think, the longest reset of them all. A few lurches there, but the boat was moving along a couple knots and got the job done. Got it stopped, no problem. Next is more reset testing, but this time with long chain. We've got 80 feet of chain, still at 5:1 scope, same seabed, and same idea. Run the boat up overhead and try to make the anchor, I'm really trying to make the anchor fail. That's the whole point of this. It's kind of a worst case nightmare scenario. But this anchor does not have nightmares. It's a sweet dream. It resets every time. I'm not going to show you all 10. They are boring. I think the fifth one here, last one I'm going to show you, is the longest of all the drags. This one here. Looks like it's on its side for a little ways, but no, not long at all. It digs right in and holds a good burst of power over 500 pounds. The anchor did pick up a hitchhiker for the last 4 resets. Didn't matter. Worked perfectly. That is a fisherman's gaff, I believe. I've never seen such a long, slender one like that, but indeed, I now have a nice, sharp gaff. Not much of a fisherman myself. Maybe I'll give it to my father. I'm now continuing with the resetting, but this time with the roll bar attached. Got the rode back to the short chain version, so we can expect full releases on each reversal. I'm going to show you all 10 of these so we can scrutinize, and it's my view that the anchor is actually worse with the roll bar. I'll let you be the judge. That first reset happened pretty quick. The second one was also pretty good. And that took a little longer, but notice that on these bursts of power that I'm giving, the anchor just isn't as firm. I see more motion with that over 500-pound burst. Much longer drag. And still creeping ahead right there, and then it released again. Fairly solid on that set finally. Another longer drag. So yeah, once again, I think it was better without the roll bar at resetting. There the anchor got airborne. It must have been going a little faster, and I think it had the opportunity to wash away the mud, and that once it finally landed, it reset real well. And that was the last reset. So when I was done, I thought, well, let's see what it can do for just straight line holding. And it wasn't great. That was released at 690 pounds. And we got a really good look here at seabed packed in. It's right up against that roll bar. It's reluctant to set. It eventually does, but it only goes in about halfway. And I give it two more tries, and it releases twice at 335 pounds of pull. So at this point, the anchor is marginalized terribly by that wad of mud. I'll give it some credit for achieving some resetting in this condition, but very, very little holding power. It's hopelessly fouled. Maybe if you drug it for a really long way, it's maybe the mud would get washed away, but it would seem it would collect it just as fast as it shed it. We see a remnant of mud that was up against that roll bar. I have to assume that at times it was fully packed in. Now we'll do another reset test, but with the long chain. See how that compares with the short chain with the roll bar installed. And I would have thought that maybe the anchor would be similar to with the short chain, but it's actually much, much worse. And I guess the theory is that on those short chain reversals, the anchor would release fully and move pretty quickly, and maybe that was an opportunity for mud to fall away. If the anchor is just pivoting in the seabed, maybe the mud just it just stays jammed into the roll bar in the back of the anchor, and well, this is the result. This drag here was endless. I stopped it, started it, no resetting whatsoever. I scrutinized the footage as carefully as I could. I didn't see any weeds or sticks or any other debris. It was just mud. Never did reset. So again, maybe on those full releases, it gave it an opportunity for the mud to wash away. One could only imagine the difference in the galvanized steel version. The assumption is that galvanizing is less slippery than the polished stainless, and maybe a galvanized anchor would even have more mud adhered to it. The anchor did shed its entire load of mud on retrieval. Final test for this video. Still got the roll bar attached, still have the long chain, still at 5-to-1, and still in the sandy mud. Just a straight line pull with a nice clean fresh anchor, no reset jazz, just a straight line. Let's see what it'll do. Unfortunately, turbidity is not letting us scrutinize the motion or depth of burial at this point. At the camera speed, normal time now. And at 750 pounds, the anchor releases fully. Note that without the roll bar and with short chain, it held, well, it was about 1,000 pounds when it released. So in every way, in this seabed, the roll bar appears to be a hindrance. Pulled out at 3,800. I purposely dragged it around with a vertical chain to clean off mud. Not sure if it had mud or not, but I didn't want to lift chain, anchor, and mud. Well, I gotta say I was disappointed in that performance. I thought that we had a real game changer here. Given the great pricing for these anchors, heck, it wouldn't have to be the best in the performance categories if it was just, you know, above average. It really would have been something. As it is, the anchor is better than Lewmar's other popular anchor, the Delta. We don't know if a galvanized Epsilon would do as well, but if it did, that galvanized Epsilon's price is so favorable, that would still be a decent anchor for someone. You know, the anchor's not terrible. I'm comparing it against the world's best, and the anchor certainly is workable. On the ranking chart, the anchor is not the lowest in performance, but it is certainly near the bottom. The total average score is improved or helped by the out-of-water categories. The four right-hand columns, self-launching power, tip to total weight, galvanizing, and engineering, there it scored quite well, and that did bring up its average. However, in the in-water performance category, it only gets a 2.5, and there's only a couple other anchors that are worse. Among them is Lewmar's Delta. It's just below it with a 2.4. I have not populated the clean sand veer, clean sand holding, and soft mud veer. When I get more testing done, I will get those parameters plugged in. Soft mud holding was a 2. Cobblestone holding was pretty much non-existent. I gave it a 1. The veer in the sandy mud, I gave it a 2.5 compared to all the other anchors, and the deep set sandy mud, a 3. And the far left column, reset testing, that's this anchor's good spot. That's really the only place I can say that it performs better than average. So overall, again, it's a bit of a disappointment. We have to acknowledge and give a huge thanks to the gentleman who submitted this anchor for testing. It was brand new and brilliantly shiny. Knew it wasn't going to be as nice when he got it back, but he donated it for testing anyway, so thank you. Big thanks to the people who are sending in money to keep these anchor tests going. Thank you so much. And to everyone else, thanks for watching. So long.